Any one answer. Any one, I need one person to be answer when I'm teaching. Okay, so I can understand because I can't see your faces. So everybody is in.
Ma'am, you can start class.
Yeah, I'm starting. I want to share the syllabus first. So we need to know what is the basics of our syllabus. कौशल ఒకసారి ఫోన్ ఏనా
Yes, ma'am.
Ma'am, not getting your voice, ma'am.
हेलो just want to share the screen. క్లాస్ లో ఉన్నాను యా యా yeah hello can you see the syllabus ma'am mechanics of particles
Yes, ma'am.
yeah okay so this is your sem 1 right so do you have any idea about our complete syllabus we have the topics right I need some answers before we start to the topics. I just want to tell you the basics of the what is a particle. So we are talking about mechanics of particles. So what is a particle? Anything which is having any element or any electron or neutron, proton, atom, molecule, anything we call it as a particle, right? Yes or no? What is
Yes,
what?
ma'am.
Anyone, please respond. So anyone to respond. So it will be like interaction. It will not be like one man show. So I need some interaction from your end also. So you are done with your intermediate level. So now you are in SEM 1, that is mechanics of particles, basics of physics, you all know. So what is a vector? So we are talking about particle, mechanics of particle. Mechanics means what? We are giving some external force to that particle. So then it starts working. Do you get it? So introduction of vector calculus, linear momentum and collisions. Kinematics is your topics. Okay. So introduction to the vector, what we are going to study, representation of vectors, different kinds of vectors, some simple properties of vectors, scalar products, scalar field, vector field. So many other topics are there. Okay. So I'll just explain you the main concept. You just try to understand the basics of the topics. So when you read this theory, you will understand what is a vector, what is a scalar, what is a mechanics, what is a particle. If you know all these basics, no, once while you study by yourself also, it will be easy for you. For you people, no need to teach line by line in school level. So you need to understand the basics of the topics. And what is the depth of the topic, why we are studying. Why we are studying first introduction to the vector. So what is a vector? Please, can anybody tell me what is a vector? Already you have studied in your school level, intermediate level also. Tell me what is a vector? Anybody can answer? I'm not going, see, these are the topics we are going to study, discuss
Ma'am,
today.
excuse me.
Yeah, tell me.
My vector is a magnitude and direction that is usually represented by a part of straight line, ma'am.
Perfect. Where you have both magnitude as well as direction is a vector. Okay, what is
Yes,
a scalar then?
it has only direction, ma'am.
There is no magnitude.
No magnitude, ma'am.
Correct? Everybody?
Only magnitude, ma'am. No
Only
direction.
magnitude is present, no direction, ma'am.
Understand? So we normally we just get confused what is a scalar and a vector. Vector is nothing but where you can have both magnitude as well as direction. But in scalar, what happens? There is no direction. Correct or not? You need to
Yes.
answer me.
Yes, ma'am. Correct, ma'am.
So why vector means why we are talking about vector? Because now we are focusing on this year semester 1. Completely we will talk on vector only, not about the scalar.
Ma'am,
Okay.
vector means velocity and force, ma'am. We talk about.
Okay, that all fine. Why we want to talk much about vector? We are always going to talk about what is a vector. Vector is helping this way, that, this. This whole topic is on vector. Whole introduction for the unit 1 is on vector.
Ma'am, to measure the direction of magnitude and those all, we need vector.
Yeah, why? Where you have both magnitude as well as direction, right?
Direction.
See, I'll just take you a best example. Vector and scalar. Scalar is nothing but it shows only magnitude. There will be no direction. But in scalar, what you can do? For example, if I'm taking a temperature, I'll speak about scalar, then I'll talk about vector. Okay. Yeah, please keep mute, no others. So scalar, in the scalar where you can find magnitude, there will be no direction, right? So why? Because if I'm taking about the temperature, if I want to calculate about a temperature, okay, the temperature can increase or decrease. You get it? The best example of a scalar, the temperature may increase or decrease.
Decrease.
Okay. In that such cases, we will use scalar product. Understand? For
Yes,
example, if I'm boiling a water, small simple examples I'll give you. No need to go with a complicated. We feel that physics is so complicated, but it is nothing. It's simple, general knowledge and general things what we use in our daily appliances. We use in that only. Okay. If I want to boil a water, I can increase the temperature or I can decrease the temperature. I can calculate both. Right? It can increase or it can decrease. The temperature can vary from 100 degrees to 200 degrees. So I can calculate from 100 to 200 or 100 below also I can calculate. Yes or no? So where we can be used in the thermometers, we can use in temperature raising and in decreasing and increasing. Wherever we want to find the temperature to calculate, there all the scalar products means mostly molecular water molecules in that type we are going to use in the scalar. That's why we don't talk much about scalar in this, because why vector is more helpful, because we are talking about the particles. We are not talking about a molecule. Okay, particles and molecules. Molecules we call it as which can disappear. Water molecules will collide with each other and it can disappear, right? So when we talk about the particles means what are the particles where it has magnitude as well as direction. Means what are the examples we can take? Can anybody tell me examples? For scalar I told you. So it is fixed in your brain. So scalar product means where it can be used, it can be used as a temperature where it can increase or decrease. Clear? Clear, students? Scalar, everybody understood, I hope.
Yes,
Right?
ma'am. Understood,
Yeah.
ma'am.
Good. Then now we are talking about vector. Very, very, very important, because if you understand vector, all the next topics will be so easy. No need to feel like it is so complicated. Vector, where it has both magnitude as well as direction. In where we are going to use this vector. Tell me any one example. Whatever you get in your brain, you tell me. Even if it is wrong, also no worry. You just try to answer. Anybody? Anybody? What is a vector? Where it is having both magnitude as well as direction. So where this vector is going to be helpful? Where we are going to use? Why we are calling it as a particle? Mechanics of particle.
Ma'am, excuse me, ma'am.
Yeah.
Ma'am, it is used to
Who is speaking?
ma'am, Rohit, ma'am.
Yeah, Rohit. Tell me, Rohit.
Ma'am, it is used in weights, ma'am.
Used it?
Weight.
Weight.
Yes, ma'am.
Particles.
Yeah,
No,
particles.
Weight means where, okay, if I'm throwing a iron ball, it will have a proper direction.
Yes,
In that
ma'am.
way you are telling.
Yes,
But
ma'am.
I'm
Yes, ma'am.
talking little bit in depth. In depth of the particles where we can't see through our eyes.
Yes, ma'am.
We can't see through our eyes, but it works.
Yes, ma'am.
I'll just give you one hint to try to catch it. If I'm taking a iron rod,
Yeah,
okay.
okay, ma'am.
So in a rod, iron rod, where it has some particles. What are they? Electrons.
Electrodes.
Right?
Yes, ma'am.
So all these electrodes or electrons, what it does when an external force is given, if I'm not giving any external force, okay, mechanical force, nothing is given. Still what happens? All the electrons gets ready to be produce some charge.
Yes, ma'am.
So that's what we are talking about the particles. So particles and vector, where magnitude and direction, what we are going to study is in depth of the particles where we can't see through our eyes. Through our eyes, which we can see, we can talk it so simply. Everybody can talk, right? No need to be a physics student or physics lecturer. Anybody can talk. But we are a physics students where we need to go in depth of the subject and we need to imagine how the things are going to be applied and how it works. For example, we are using current every day, every single minute, right? Second, how this current is keep on producing? How? Because the particles are the electrons which are helping to flow the charge continuously. Means all the electrons are keep on vibrating and producing the charge. Why? Because we have given some external force. If we don't give an external force, there will be no power. If you are off, there will be no current. If you are on, if it is power is on, the continuous process starts. That is what is about the mechanics of the particles. External force is being given, then it starts conducting and it starts producing the flow of the charge. This is the depth what we are going to study about these vectors, how this direction is helping, what is equilibrium, how the charge will be flowing from one particle to another particle, one electron to another electron continuously. Got it? Okay. So
Yes,
this
ma'am.
is what, yeah. So you understood, try to every class, you just try to understand the concept. Concept is clear, content is clear, then everything will be easy. No need to worry that this is, I don't know that, I don't know. Okay, try to just catch the topic. Then everything will be simple, very simple, I'm telling you. Okay, so here we have the objectives. So now I'm going to the introduction, whatever the introduction which I have given. So what are the force introduction, what we can discuss about the physical quantities such as force, velocity, momentum, speed, work, and so on. This innumerable physical quantities are classified as vectors and scalars. Depending on the physical quantity, magnitude and its directions are classified above two categories, that is vector, especially especially follow certain rules. What are they? Of addition, multiplication, uh, commutation, etc. Not only this, a vector is component and it is integral are based on certain theorems are enumerated, which are mostly applicable in state, electric fields, gravitational, and also fluid mechanics. So many fields we are going to use this because this is the basic. This, if you understand what is a vector, how it works, why this is going to help in all the particles, next semesters will be easy to understand. Because if you don't understand this, you don't understand next topics. Okay, so for example, if when a vector physical quantity is expressed from point, the region of space by continuous vector function A of x, y, z, the vector field examples are gravitational, magnetic, electric, intensity, etc. Shall I tell you one more important and interesting? Do you know whenever the electric field is there, there will be a magnetic field. Do you know that? Wherever electric field, in the nature also we have electric field as well as magnetic field. When electric field is producing, perpendicular to that, magnetic field will be all the time it will be there. So what we will do, whatever we require, we are taking that. And what we don't require, we are not taking. Understand, we are continuously producing electric power. So what we are neglecting, we are neglecting magnetic field and we are just taking electric field. When we are giving voltage, current is produced. Okay, so these topics will be continued all the time. So here, the basic is about the vector field can easily be understood with the help of some examples. What are they? Let us see. Example we'll discuss. Consider a body which is rotating about an axis. The velocity of the body is different at a point. That the velocity is a function of position of the point. Hence, the velocity is a vector field. Consider the heat flow through a block of material whose different phases are maintained at different temperatures. There will be a flow of heat from hotter phase to colder phase. The heat will be following in different directions in different parts of the block. This heat flows is a vector field. Means what it is happening, it is flowing in one direction. All the time, vector field is nothing but it flows in one direction. Okay. So here we can take V is equal to I minus J minus K, etc. Like this, many more examples coming across in physical problems can be taken into consideration. So this is a whole concept of your scalar and a vector. So we are going little depth. Depth is nothing but what we are talking about. What is the force? What is the velocity? What is the acceleration? What is the magnitude? What is the direction? What is the density, volume, length? This all comes under the basics of the vectors. Understood, everybody?
Yes, ma'am.
Okay, fine. So, see, why we need to discuss all about this force, velocity, acceleration, and everything? Because if I'm taking an example of a car, or a vehicle or a cycle, whatever. Okay. So what I'm applying, there is a force, there is a velocity, there is an acceleration. If I don't accelerate, it works. I have a car, but I don't give any external force to that. I don't on the engine. I don't give the acceleration. Then it works. Yes, it can move forward. So what I can find the distance, I can find the direction, I can find the length of the road. Yes or no? So in this way, these all concepts are going to be used in spaces of the vectors. So with this concept only, they are able to find the maps, they're able to find the length, they can find the distance, direction, magnitude, everything. Because of these vectors, we are able to find everything. So many things. See, we are Google Maps we are keeping. We are able to see the distance, how much distance we are traveling. We can find everything in our hands now. No need to travel, no need to go, no need to waste our energy. How this all been invented, how this in one single phone, everything is there. Means how much depth of the physics and electronics is being involved to implement the uses of this gadget, one single gadget everybody is carrying and everything is there in their hands. No need to wonder where we need to go, how to find out. In those days, in olden days, there is nothing. There was nothing. If they want to find out, they need to travel and they need to find it. Understand, in 2024, we are in the 20th century. So we are now able to, we have no struggles at all. No struggle. Everything is on our hands because of this invention, this hard work, this efforts, the scientists who are all worked so hard for the decades and decades, and the implementation is going like anything. These are the basic levels of the physics or electronics, whatever we are taking, that are going to be implemented everywhere. Clear? This cannot be destroyed. There will be no topic other than topics may be added, but this will be there forever. I have studied, you are studying, your children, next generation will also study these basics. Understand? So these are the main, very important basics where this implementation is being done with so much of vast research. Okay. So what we are studying is nothing, simple basics. We are just studying all the degrees, 1, 2, 3 years are only the basics. Only the basics. Who have invented, it's just studying about that. We are not inventing anything, we are not discovering something new. Just we are studying what they have struggled, worked hard, so much of knowledge, concept, everything is being implemented. So just we are studying about that. First, you keep that in your brain that we are studying only the basics. We are just trying to understand the concept. We are not inventing anything. We are not discovering anything. We are not going to write any formulas or theory or whatever. We are not doing anything else. The people who have struggled and invented and done it, just we are reading that as a novel. Okay. So we are going to see the depth, how these vectors are going to help for the force, velocity, and acceleration. Okay, I have given you the best example as a car. So you need to remember how this force, velocity, and accelerations are going to work. So representation of a vector. So let O be a fixed point in a space and P be any another point in it. Then the straight line OP bar has magnitude as well as direction. Yes, it has both magnitude as well as direction. Okay. So, for example, why we call it as magnitude as direction? Because it goes in one straight line. Even if it is taking a curve also, it goes in a one straight line. It is going in a zigzag model also, it will go in a straight line. Clear? It goes all the time in the equilibrium state. Equilibrium means all the forces are going to be flowing in one direction. One single direction. Clear? So you just read the representation of the vectors, how these vectors are going to be used for the speed in a scalar quantity, whereas velocity is a vector quantity, directions must be specified in order to define a vector. We are talking much about vector, where you have both magnitude as well as direction. So different kinds of vectors. So zero or null vector, and what is a unit vector? So what is a unit vector? Next is your collinear or parallel vectors. So we are just going to talk about this. Different kinds of vectors are going to be used. So here you can see the vector which starts from a arrow. A arrow will be there. All the directions will be the same. So whatever the, it might be in a circle, it might be in a square, it might be in a rectangle. Still it goes in this arrow model. It does not have any zigzag model of this line. Clear? So equal vector, equally which flows. Next is equilibrium. Equal vector means all direction will be in the same. See, this may go first, this may go second, this may go third, but all will go in an arrow straight line. The direction will be in one way. So if I'm taking a curve, for example, if I'm taking a curve, still it goes in a straight line in the curve this way, this way. Understand? So what I'm talking about, if two equal forces acting in the same directions are applied in different points of a rigid body, and they may have different mechanical effects. So what is a rigid body? Anybody can tell me what is a rigid body? Anybody can answer. Because this will be the next topic. Next topic, we are going to talk about the rigid bodies.
Ma'am,
Huh? Yeah, take it over.
it is a solid body, ma'am.
Okay. Anything more? Correct. But still, I need little more answer. Let me tell you, what is a rigid body is nothing but a fixed. The position is so fixed, it does not move from one place to another place. It cannot be moved. For example, if I'm taking a pillar, poles, transformers that are fixed, that cannot be moved all the time, no? All the time, it is fixed.
Yes, ma'am.
The electric poles are there that are fixed. Means that is fixed. The flow of the charge will be flowing towards that rigid body, but that cannot be moved from one place to another place. That is nothing but rigid. Rigid means it is fixed. Or it is a strong body where it cannot be placed from one place to another place. Okay, that's why we say sometimes don't be so rigid. Because we are human beings, we should not be rigid. We should be little flexible. We can move, no, from one place to another place. We can do all. But why we call it? We call somebody as so rigid because if they're fixed with the word or something, they will not come down. That's why we call it as so rigid. They are so rigid. Okay. So the fixing of one position and it does not change whenever we want, that body is nothing but rigid body. Okay. Some simple properties of a vector. So what are they? So addition of vector. Okay. So addition means how we can add from one line to the other. This can be added, this can be added, this can be added. Right? So addition of the vectors, subtraction of the vectors, where you can also minus the vector lines. Okay. So multiplication of vector by a scalar and the scalar product of examples. Let us see the examples. When mass scalar is multiplied by velocity vector. See, very few classes we get. If only on Sundays I have to take the class. I can't read line by line. I can't explain. The topics will be explained. You just go through it. You study it. If you have any doubts before starting the next class next week, you can ask me the doubts. Okay. If I teach line by line, the whole class will be over. We can't complete the whole syllabus. So every class we need to complete at least one unit, one chapter. Clear? So this is the scalar products of two vectors. So let me tell you how this, when mass scalar is multiplied by velocity vector, then the product NV represents momentum. So what is momentum? Which is a different quantity, that is a vector. Momentum means what? See, main topics, main words I'm explaining you. Momentum. Anybody? You need to remember all this. Momentum is nothing but which is moving from one place to another. The force is applied. When a force is applied, it has some momentum. Electrons are there, but it does not move. Why? Because there is no external force is being given. So one particle is moving from another to another. Why? How this it is moving? How? Because the force is acting to flow the charge. Then a momentum starts. The flow of the electrons will be having a momentum where it can be continuously flow. There will be no break. If there is a break in the flow of the current, what happens? Fluctuations will be happening. For example, if I'm taking a tube light, so what happens? The continuous flow of the light is having. We are able to see the light continuously. But sometimes what happens? It fluctuates. Why? Because the capacitor is not having a proper charge. It destroyed. So that what happens? It glows, it offs, it glows and it offs. The fluctuation takes place. Understand? So the momentum is nothing but which moves from one place to another place continuously. So similarly, when mass multiplied by acceleration, which are scalar and vector quantities respectively, result in force, which is a vector quantity, that is equal to force is equals to mass into acceleration. Okay. F is nothing but force. All the time we will talk about force. That is mass into acceleration. Acceleration is nothing but which is started, drive and driven. Means which is continuously, when you start the car till you reach your destination, you will keep on give the acceleration, no? You can't stop in between. You keep on give the acceleration because the force is applied, the mass into acceleration. Where you give the acceleration, you continuously driving. Okay, you are continuously driving to reach your destination. So thus, we draw conclusions that when a vector is multiplied by scalar quantity is given, gives result to the vector quantity, but this is not always. Okay, so scalar product of two vectors, that is what scalar products? A and B, we have defined the products of magnitude and vector, that is A and B. And the cosine of the angle between them is A dot B is equal to AB cos theta, where theta is angle between the two vectors. In case, we can take this theta is equal to 0, A dot B is AB. They are both are parallel to each other. Then we can take this theta is equals to pi by 2, that is A dot B is equals to AB equals 0. That is the two vectors are perpendicular to each other. Okay, vectors are parallel as well as perpendicular to each other. So the scalar products of unit orthogonal vectors I, J and K have the following relations. These are the relations where you can just find out. The scalar products of two vectors is equal to the sum of the products of this corresponding X, Y and Z components. You just go through this, you'll understand. Vector products or cross products of vectors. Okay, so example here, yeah, I just want to explain this. So vector products or cross products of vectors. What we can do? The vector or cross products of two vectors is defined as a vector having magnitude equal to the product of the magnitude of two vectors. See here I have taken A bar and B bar. Bar is nothing but where you have both magnitude as well as direction. So if I'm drawing this can be also the direction. It can be this way, this way also, right? I can take, see for example, if I'm able to calculate this plane, I can calculate for this, I can calculate for this, I can calculate for the whole circle. If I'm taking the whole circle of the vector, I can find. The direction can be this way, this way, this way, also this side, this side. The whole vector I can find. So what I'm just going to find every time whenever we are calculating to find out anything, what we will do first, we want to simplify it. To make it easy, we will just take one direction. So I just want to calculate what will be the direction and what will be the cross product of this vector. Okay. So let us take if A and B are two vectors. A and B are two vectors, and the vector product is A into B, which can be written as A into B is equals to AB sine theta tau, where A and B are magnitudes of A. Why magnitude? Because it has both magnitude as well as direction is also there. So theta is the angle between them. Then tau is a unit vector perpendicular to the plane of A and B. Then the directions of A and B is given in the right hand rule. So we will follow always in the right hand rule. Okay. So the magnitude always what happens? It follows in the thumb rule. We have next topics, that is your magnitude as well as how this magnitude direction will be showing. That is next topic we will discuss. Okay, the magnitude of the vector product of two vectors mutually perpendicular, that is the right angle with each other is equal to the product of the magnitude of the vector. So I'm just calculating this area. So if I'm done with this area, I can find out for this area also, this area also, this area also. So here you can see N is perpendicular. N is perpendicular to the A and B. Okay, the vector product A and B is equals to A sine theta. So N tau is nothing but AB sine 90 degrees. This is, we call it as N perpendicular, or we can, which is having the magnitude as well as the direction. Okay, so this is AB of your N is perpendicular. So the vector product of two parallel vectors is a null vector, that is 0. So what happens? A into B is equals to AB sine theta, N is equals to 0. So the vector unit for orthogonal vector I, J and K have the following relations. We have orthogonal vectors which we have already seen in the starting topic. There you can find this relations. So the vector product of two vectors in terms of their x, y, and z components here. This is what I am going to discuss more. Can be expressed in the form of determinants. I just want to go and show you. So, for example, if I'm taking x-axis, okay, sorry, x-axis if I'm taking in this way, and y-axis in this way, and z-axis in this way. Okay. So what happens? X, Y, Z axis. All the time you will talk about coordinates. Coordinates are nothing but X, Y, and Z. So X axis, Y axis, and Z axis. Listen, are you people with me? Are you listening? Or it is boring?
Listening, ma'am.
Listening, right? See,
Listening,
I just
ma'am.
want,
Yes, ma'am.
yeah, good. I just want to tell you one important concept. This will be applicable all the time. Okay, X, Y, Z. You always want to calculate any particle, any coordinate, any. For example, if a light is falling on an electron, what happens? Electron starts vibrating and re-radiating. Listen the concept. If I'm taking x-axis, y-axis, and z-axis, I want to find the coordinates. Means particles or electrons, atoms, neutrons, protons, whatever it is. So I just want to see how these electrons are producing the charge to another electron. I just want to find for one single electron. If I'm able to find for one single electron the other electron, I can find for n number of electrons, right? N number of electrons. So what I'm doing, I'm taking a one single electron. I just want to draw and show you. Paint, I'm trying. Okay, this we take it as Z. Okay, this I'm taking as X. Able to see, right? Everybody?
Yes, ma'am.
I
Yes,
don't
ma'am.
know much to use this thing, but I'm just trying to see here. Why X, Y, Z concept? I just want to see. If you understand this concept, everything will be easy. So if I'm taking an electron, circle it should become. Okay. So for one electron, what I'm taking x-axis, y-axis, and z-axis. So if I'm able to find for one single electron, how this charge is going to produce, how a light is falling. For example, a light is, instant light is falling on this electron. So what happens? Normal electron will be ready. It will be ready. What it means? Some external force is being given to this electron. So what happens? This electron starts vibrating in this way and re-radiating and hits the another electron. This is the concept you need to understand. So it starts re-radiating, it starts vibrating, and it re-radiates and hits the other. It doesn't mean that this electron go and hit. The energy will be transmitted in a wave. Understand? This energy will be transmitted in a wave. So all the electrons will be starting flowing and continuously it happens. Continuously flow of electrons will be vibrating and re-radiating, vibrating and re-radiating. That is what is happening for the flow of the charge. Okay, so here we will keep on talk about XYZ axis, how this XYZ axis is, if we are able to find for one single electron, we are able to find for the n number of electrons. If I'm finding for the single electron magnitude as well as direction, I can find for the n number of electrons, neutrons, protons, whatever I can find for the magnitude as well as direction. So all the time we will take a single one particle, then we will talk about multiple. If we take sigma, we can calculate. Clear? So here, if I'm talking about then A and B for I, J, K, where I can find for AX, AY, AZ, BX, BY, BZ, CX, CY, CZ. Like that, so on I can take now for here I'm taking A and B direction. I can find for A and B, then I can find for n number of particles. Clear? If I'm able to find, see, I just here, I want to find the magnitude as well as direction. The flow of the electrons are there. Charge is there. If I'm able to find for this flow of the electrons or the charge, how this magnitude and direction is taking place, I can calculate for this whole concept of the magnitude and direction. Understand? Able to understand? How this vibration
Yes,
is
ma'am.
happening? Yeah. How it is vibrating and radiating. Re-radiating means the electron to the electron, the energy will be transmitted in a wave. And one more, the beautiful concept of the physics is nothing but where we are able to understand is everything is in frequency. Everything, whatever you take, if you take water, even if you take heat, air, everything, sound, what I'm talking and what you are hearing is also going in a wave. And it's a God created frequency that cannot be created nor destroyed. It is a God's gift. Everything will be in a frequency. Whatever you think, whatever you understand, everything is in a frequency. Everything. Means frequency is nothing but it's in a wave. Wave. Everything is in a natural frequency where it is in everything, whatever it flows, whatever you have in your nature, everything will be in a wave. Clear? So here we are going to talk about scalar and vector fields, how the scalar field is going to helpful, how this vector field is helpful. Why we are talking about X, Y, Z? Now you understood, right? If I'm taking a one single particle, for one single particle, I can find for X, Y, Z directions as well as magnitude. Okay. So what are the properties of vector field? Define the scalar and vector field is done. So summary of this. So here if I want to find for X, Y, Z, where I can find for the phi of X, Y, Z, examples of scalar field are electric potential due to the single positive charge and temperature distribution throughout the space. See, I can find for one single electron, I can find for a number of electrons. If I want, see, if I'm giving a big uh, sheet, okay, electrons are flowing. If not, let us take a sheet of iron sheet I have given you, or aluminum sheet, copper sheet, whatever. So I just want to find how much charge is going to produce in that sheet. So what you will do? You will take one step by step and step by step, and you will calculate. So it will take 10 years to calculate one single sheet. If you want to find for one electron to another electron, another electron to another electron, you can't waste that much time, right, to find out. So that's why what we have done for one single electron, the charge of the flow, the direction of X, Y, Z can be calculated. Then the flow of the charge will be the same because it has the same magnitude and same direction. It does not differ, no? It will not increase or decrease like scalar or temperature. It flows in one direction, flow of the charge. But how this can be calculated when the external force of the electric potential is given? Okay, according to the flow of the external force, that way the current will be flow. All the bulbs will be the same energy, differs, right? Hello?
Yes, ma'am.
What I'm asking is, all the tube lights will give the same energy, same light? It differs. Tell me. Tell me. Anybody? Light, the flow of the charge of the light, tube light, small lights, big lights, you have, no?
Yes, ma'am.
Every light cannot produce the same flow of the current or the
No,
charge. It
no,
differs.
ma'am.
No, ma'am, different, ma'am.
Yeah, that's what I'm asking. Okay, so to find out, so how we are fixing the charge in this tube light, this much of the flow of the light. In small tubelets, how we are fixing, how we are calculating because of the one single electron flow of the current. If we are calculating that, we are able to fix for the size of the tubes.
Yes, ma'am.
Size of the tublet. So these are the fundamental basics of the flow of the chart where we are taking X, Y, Z direction of the phi. Examples of scalar field or electric potentials we are seeing with positive charge and temperature distribution throughout the space. The pressure distribution in a fluid. A vector field associated with a vector with each point in the space by a continuous vector function that is A of X, Y, Z. Then the region is a vector field, gravitational, magnetic, electric, or examples of it. So you can take the gravitational force, magnetic force, electric force can be calculated. So if I want to find for the magnetic field, I can find for the magnetic field. We are talking about electric field, no? Till now, how the electrons are flowing continuously. In that same way, magnetic field will be there. Magnetic gravitational field also can be taken and we can find for the vector field for that also. Clear? Okay.
Yes, madam.
Okay. This is done. Next topic is your vector calculus. Unit 2. See, if you are able to understand for the scalar and the vector field, vector calculus will be simple. What is divergence, derivations, significance, what is gradient for the scalar field, what is a vector field. Okay. So these all topics also I'll tell you in the next class. Surface integral and what is surface integral line. Very simple. Now you understood the concept of scalar and a vector field. These are very divergence means Divergence means how it is going to, let us see. Let me explain you. The 3 minutes are there. Okay, grad, L and divergence of a vector field. What is a divergence of a vector field? It's nothing but delta we take. Okay, we divergence is nothing but delta. To calculate that divergence of A, B vector fields of I, J and K. Okay, if I'm taking X, Y, Z in a region of space, divergence. So I want to find a divergence. Divergence is nothing but what happens if I'm taking a field where it can be diverted. It can be diverted in this way, this way, this way. So for that, to simplify it, I'm taking a vector. The operator delta can be involved in the multiplication with a vector, the scalar or dot of product operator delta with a vector, that is called divergence. Okay, that is called divergence, where you have the flux. Flux is nothing but one single line. One single line is nothing but a flux. Okay, fluxes means n number of fluxes. So 1 to 10 if I'm taking. If I want to find for one single flux, it takes time. So all the fluxes together are what I'm doing, calculating with a divergence. Simplify. So physics, it's a theory. We are understanding that should be calculated. That is nothing but mathematics is being implemented. Without getting the calculations, we can't derive. So I'm talking about single line. So n number of fluxes will be there. Flux is nothing but one single line with the arrow. Okay, like that, n number of fluxes will be flowing continuously. So to find out, to simplify that, divergence is V. Del is nothing but divergence dot A is equals to I of dou x plus J of dou by plus K of dou dou z, because x, y, z directions with a vector of A and with a divergence, where I can find the IA of x plus JA of y plus K of A of z. So here I can find dou AX of dou x plus dou AY of dou y. X, Y, Z are the directions. So this I can find the divergence of A of del of A of dou AX by dou x plus dou AY by dou z. So if I could find for the vector of A, I can find the vector of the B, C, D, whatever I can take. Okay. X, Y, Z axis will be the same. Clear? Magnitude which I am applying, magnitude as well as direction. That direction can be this way, that way, anyway. So derivations of the expressions we have. So here the derivations of the what is derivations of the expressions we will see in the next class. Okay. Significance of the divergence. What is a gradient of a scalar? This I'll explain in the next class also. This all we will discuss. Within 10 to 15 minutes, we'll complete this, and next, curl of a vector. Simple. Simple. See, now we understood what is a vector and what is a scalar, how it flows, how the direction takes place. I can take a curl, I can take a circle, I can take a square, whatever. I can take any number of different directions. I can calculate in any way. Any way I can calculate. Clear? The direction might be, that might be in circular motion, sphere, circle, square, rectangle. What I can do, the flowing of the vector will be in one direction. Direction will be the same. That might be, the shapes may be different. Different shapes may be different. But the direction will be the same. Clear? Everybody? So, see you all in the next class. This next class, I'll complete all this Stokes theorem. Simple. Very simple. Cos divergence theta. All easy, ma. No need to worry. Only the thing is that you need to understand and you need to focus and you need to practice. Physics and maths, the thing is that you need to practice more. Concept, if you understand what is a flux, what is a scalar, what is a vector, what is a momentum, what is a velocity, acceleration, these all concepts if you understand, no? Rest of the thing is simple. Okay? have another class, because if not, I can continue the class. But you have another class. So I'll wind up today for this class. So I want everybody to present in the class and little be active. If you have any doubts, you can ask me in the next class.
Ma'am, excuse me, ma'am.
Yeah, tell me, Rohit.
Ma'am, any important questions are there, ma'am, to prepare for SEM?